My name is Dan. I'm a fourth generation Coloradan, and I have purchased some land here in Crestone to build this house. But the first step that I took was to get power on site and bought this turnkey system that was dropped off the third day of my construction and powered everything that we needed to power on site. So all of our tools, I even welded off this unit for part of the project. And now it's trenched in and hooked up to the house and powering everything in the house. So this is a house that I have been building for the last year. And the third day of the build, I got this solar panel set delivered, dropped off, and installed on site. It arrived completely turnkey, ready to go, producing energy. And we immediately plugged tools into it and started working on putting down the footers for this house. So it's been really useful from day one, powering this entire build. And now we have it trenched into the house. It's tied into our main panel, and it's running everything in the house. So as a first-time home builder, there were a lot of moving parts happening right at the beginning of the build and throughout. But one of the things that happened when I started talking to people about solar is I realized I needed a concrete contractor, I needed somebody to assemble the racking, or I needed to do it. I needed somebody to do a little excavation. I needed panels to show up. They needed to be wired together, and then an inverter put in, and all of these steps needed to happen, and all these pieces and parts needed to come together. And I had enough things to worry about and think about in terms of materials and people and contractors and subcontractors that having this thing literally show up, already put together, ready to work, just checked 5 things off my list and got me going and had power moving for me on site immediately. So that was a huge win as far as all those pieces and parts and complications happening and scheduling. So. Thank God that's rated for 100 miles an hour, although I don't think we're there yet. But it is keeping my solar panels steady here in Crestone and keeping my house powered. So let's take a look at the system. So the first thing about this thing is that we have a really beefy framework that is anchored to the ground. So that avoids having to do a bunch of concrete and a bunch of steel posts and a bunch of additional laborers and contractors on site. The unit came completely assembled, slid off a truck, and then was mounted to the ground with earth anchors. So the system in total is the solar panels, the rack, but also we have an integrated generator that fills up the batteries when they drop. We're off grid here. We've got a battery cabinet with 5 lithium-ion batteries in it. And then this Solar inverter, which can handle even a larger system than the one I have here. So all of this together arrived on site. Some receptacles on the outside for plugging in extension cords. Stretch those over to the house as we need them. But that ran everything that we needed to build this house from start to finish. And now it's tied in to the breaker box inside, and it's running the whole place. So as you can see today, here out in the valley, we have a lot of wind, which is why we have these sand dunes down here. This system is rated for 100-mile-an-hour wind. We're getting there. We do a pull test on these connections to the ground, so we make sure that they are sufficient for what we need to do. We have a couple of different mounting systems as well. We have a ballast system where we put a tray with gravel in the bottom of this array, or we can weight this with concrete blocks. So if your surface does not really allow you to do earth anchors, we've got other solutions to hold this thing to the ground. We have these receptacles mounted to the side of the battery bank, and we're able to use those straight away once this thing was mounted to the ground to tie in our tools. So compressors, chargers, had a table saw, chop saw, and in fact a welder on this site running off these panels. So a lot of people are concerned about the amount of mining and secondary processes that go into making solar panels, and it is a concern. And I think the bottom line is there's no free lunch. If you want energy, you've got to have a structure, you've got to have material. That material has to come from somewhere. But if you compare the amount of material that's coming out of the ground to create a set of solar panels and the amount of material that needs to come out of the ground to run this house for the next 25 years, which is what this panel system is going to do, there's no comparison. And that material is coming out of the ground and it's being burnt. It's turning into carbon in the atmosphere. This material is coming out of the ground, it's getting turned into this solar panel, and it's creating energy for the next 25 years. The other part of that is that just like all the rest of our technologies, our cars have gotten more efficient, our trains have gotten more efficient, all of the motors and engines in our world have gotten more efficient over time. And so when we're looking at these solar panels 25 years from now, I think the folks will look at them and say, wow, we're doing something that's 10 times more efficient, or we can recycle these panels into something that's going to be 5 times what they are now. So in terms of resource usage, like I said, there's no free lunch, but at the same time, we're pulling something out of the ground and using it for 25 years rather than using it for a day and it's burned and it's gone. So I think that's a positive all around.